Welcome to WikiPodcast. Today we're taking a deep dive into the extraordinary life and enduring legacy of a true pioneer, a figure often celebrated as the Queen of Code Web, the remarkable Grace Hopper. As part of our History Makers series, specifically focusing on tech and innovation leaders, our mission today is really to unpack her fascinating journey. From her insatiable childhood curiosity right through to the groundbreaking contributions that fundamentally shape the world of computing as we know it.
Exactly. And you're about to discover how one woman's unique vision, her unwavering persistence, and a profound belief in simplifying the complex completely revolutionized how we interact with technology. It's not just a story of technical innovation, it's a testament to military service, profound mentorship, and a relentless passion for making computers work for people, not just, for a select few mathematicians.
That drive started incredibly early, didn't it? Grace Brewster Murray, born in New York City, December 9th, 1906, eldest of three kids, Scottish and Dutch roots.
Right. But it's her inherent nature that's so fascinating.
Yeah.
Her defining trait, curiosity, was evident from an almost unbelievable young age. I mean, can you imagine a 7-year-old systematically dismantling 7 different alarm clocks?
7 of them.
7. Not out of mischief, but purely to understand their inner workings. That wasn't just like childish curiosity. It was the early sign of a deeply inquisitive, systems-thinking mind. Absolutely crucial for someone who would later build entire new paradigms for computing.
Wow.
And she even famously kept a clock that ran backward. She explained it by saying, humans are allergic to change. They love to say, we've always done it this way. I try to fight that. That's why I have a clock on my wall that runs counterclockwise.
That quote alone tells you so much about her character. It wasn't just about understanding how things work, but really challenging the way things were always done. And she applied that same tenacity to her education. She attended the Hartridge School, and while she was initially rejected by Vassar College, apparently due to her Latin scores.
Just a minor hurdle for her, it seems.
Right. She was admitted the following year, and she went on to graduate Phi Beta Kappa in 1928 with a bachelor's in mathematics and physics.
And her academic journey certainly didn't stop there. She went straight to Yale University, earned her master's in 1930, and then a PhD in mathematics in 1934. Her advisor was Einstein or A. Her dissertation, New Types of Irreducibility Criteria. Well, it showcased a rigorous analytical mind. She could tackle these complex, abstract problems. That skill set would prove invaluable in the very new field of computing.
Right. And during this academic period in 1930, she married Vincent Foster Hopper, a New York University professor. They later divorced in 1945, but she kept his surname, Hopper.
That's right.
And before the war really changed her path, she started teaching, quickly becoming an associate professor of mathematics at Vassar by 1941. So she's established, highly educated, making her mark in academia. But then, well, the world changes. World War II.
Exactly. And with that same relentless drive we saw with the alarm clocks, she tried to get commissioned into the Navy.
But she hit a wall, right? Bureaucracy.
A big one. At 34, she was considered too old. Her weight-to-height ratio was too low, and her job as a math professor was deemed too valuable to the war effort at Vassar.
It sounds like they were looking for reasons to say no.
It really does. But it just highlights her incredible persistence, doesn't it? Despite all those official obstacles, she just wouldn't take no for an answer. She got a leave of absence from Vassar, insisted, and successfully got sworn into the United States Navy Reserve, part of the Waves, in 1943.
And she needed that weight exemption, too.
Yes, an exemption for being 15 pounds under the minimum weight. And then, almost as if to prove everyone wrong, she graduated first in her class from the Naval Reserve Midshipmen's School in 1944.
First in her class.
Wow. This wasn't just about joining up. It was about serving where her analytical mind could be most useful, even if she had to fight the system to get there.
And that's exactly what happened. Soon after, assignment to the Bureau of Ships Computation Project at Harvard University, lieutenant junior grade. So imagine this. She's now right at the heart of computing's infancy, joining the team programming the Harvard Marquet computer.
Also known as the Automatic Sequence-Controlled Calculator, led by Howard H. Aiken.
So what did it even mean to be a programmer back then? In the 1940s, it wasn't like coding today.
Oh, not at all. Entirely different world. Picture this machine, 50 feet long, 8 feet high, weighed 5 tons.
Huge.
A giant electromechanical calculator, really. More than a true computer as we think of it. Being a programmer meant, well, operating the machine very manually, often using switches, plugging in cables, feeding punch cards, and paper tapes with instructions and data.
Sounds incredibly tedious.
It was. Precise physical work. You had to interact directly with the machine. And Grace Hopper was one of the very first people to really program this thing, to understand its logic, its limits. She co-authored 3 foundational papers with Aiken on its operation. Her dedication was absolute. At the end of the war, her request to transfer to the regular Navy was declined. She was 38 by then, too old again.
Unbelievable.
But she chose to stay in the Navy Reserve and remained at the Harvard Computation Lab until 1949. She actually turned down a full professorship at Vassar to keep doing this research under a Navy contract.
That's commitment. And it was during this time, right at Harvard, that the famous bug story happened.
That's the one. Working on the Mark II computer in 1947. Her team literally found a moth stuck in a relay.
A real moth.
A real moth, stopping the machine. They carefully removed it, taped it into the logbook, and wrote, "First actual case of bug being found."
And that's how we got the term debugging.
It certainly popularized it in computing. It just highlights that very physical, hands-on nature of early computing.
Amazing. Okay, so after Harvard, 1949, she makes another big move.
A pivotal one. She joins the Eckert-Maschli Computer Corporation as a senior mathematician. Exciting times. She became part of the team developing the UNIVAC Array, and in 1951, that became the first large-scale electronic computer to actually hit the market.
Not just a lab machine.
No, designed for commercial and government use. A huge shift.
And this is where her truly revolutionary idea starts to form, the one that changed everything. She proposed using English words for programming.
Yes, and to us now, it sounds perfectly logical. But you have to understand the mindset then.
What was the standard approach? Why was it so unthinkable? Computers work on zeros and ones, right?
Exactly. The reigning belief, the only belief really, was that you had to speak the machine's language. Binary code streams of zeros and ones, or maybe slightly more abstract assembly codes, which were still just symbols for machine instructions like ADD or JET-MP. You needed deep knowledge of the computer's architecture.
Like knowing specific memory addresses.
Precisely. So when Hopper suggested using plain English words, she was told, very quickly apparently, that she couldn't do that because computers didn't understand English. It was seen as impossible. Absurd, even.
Oh, but that didn't stop her. That same defiance we saw earlier, she believed, and I'm quoting her here, it's much easier for most people to write an English statement than it is to use symbols. So I decided data processors ought to be able to write their programs in English, and the computers would translate them into machine code. So the key was the translation step.
Exactly. That translation program was what she called a compiler, a true breakthrough concept. Think of it like a universal translator, taking human-readable instructions, say, subtract income tax from pay, and converting them into the machine's native zeros and ones.
And she didn't just have the idea.
No. By 1952, she had an operational one, an early version, a link loader she called the A0 compiler, a working prototype.
Proof it could be done.
You'd think. But even then, she recalled, nobody believed that. I had a running compiler, and nobody would touch it. They told me computers could only do arithmetic.
Wow. The resistance was intense.
It really underscores the intellectual bravery it took to push this against such skepticism.
But her leadership couldn't be ignored forever. By 1954, she was named the company's first director of automatic programming.
That's right. And her department went on to release some of the earliest compiler-based languages, like Mathematic and Flowmatic,
which were precursors to COBOL.
Direct precursors. Her work with A0, Flowmatic, it all fed into this bigger vision for COBOL. She put it simply. I could say subtract income tax from pay instead of trying to write that in octal code or using all kinds of symbols. This wasn't just about making programming easier for the experts. It was about democratizing computing.
Opening it up?
Exactly. Before this, only highly specialized mathematicians and engineers could really use computers. COBOL unlocked entire industries by letting business folks program too.
Which brings us to 1959, a big meeting, right? CODISL.
Yes, the Conference on Data Systems Languages. Computer experts from industry and government gathered. And Grace Hopper was there as a key technical consultant. She brought all her experience, her vision.
And her persistence, I imagine.
No doubt. And that conference led directly to COBOL, the Common Business-Oriented Language. It directly extended Hopper's Flowmatic language, mixed in some ideas from IBM's Common Tran. But the core philosophy was hers. Write programs in something close to English.
And the impact.
Monumental. COBOL became the most ubiquitous business language of its time. It powered governments, businesses worldwide for decades. Think banking, payroll, inventory. So much of the modern business world was built on COBOL, enabled by her vision.
And throughout this, her Navy connection remained strong.
Absolutely. From 1967 to 1977, she was director of the Navy Program and Languages Group. She was promoted to captain in 1973, never stopped serving.
What was she focused on there?
Well, she developed critical validation software for COBOL and its compilers, pushing for standardization across the Navy. But even more forward-thinking, in the 1970s, she became a huge advocate for moving away from giant mainframes.
The big centralized systems.
Right. She pushed for networks of smaller, distributed computers. She foresaw a future where users could access shared databases from anywhere.
That sounds like, well, today, cloud computing, networks.
Exactly. She was predicting that decades ahead. She also developed standards for testing systems and components, pushing vendors towards compatibility. It had a huge effect on the industry moving forward.
Her military career itself is just incredible. She initially retired from the Naval Reserve end of '66, rank of commander, age 60, regulations.
You'd think that was it, but her expertise was just too valuable. Almost immediately, August '67, she's recalled to active duty.
Just like that.
Just like that. Supposedly for 6 months, but it became indefinite. She retired again in '71, only to be asked back again in '72.
They just couldn't let her go.
Clearly irreplaceable for the Navy's competing needs. Then promoted to captain in '73. It showed her continued leadership and importance.
And her career culminated in that very special promotion later on.
Yes, truly special. Representative Philip Crane championed her cause. President Reagan promoted her to Commodore on December 15th, 1983.
A huge honor, especially then.
Incredibly rare. And then, November '85, the rank itself was renamed Rear Admiral, lower half.
Yeah.
So she officially became one of the Navy's few female admirals. And she stayed on active duty, even beyond mandatory retirement. Needed special congressional approval. Just shows how vital she remained.
So her final retirement, that was quite something.
It really was.
Huh?
August 14th, 1986. After over 42 years of service, she was 79 years, 8 months, and 5 days old. The oldest serving member of the Navy at the time.
Wow.
And the retirement ceremony was held on the USS Constitution.
The oldest commissioned ship.
Exactly. Oldest serving member retiring on the oldest commissioned ship. Beautiful symmetry. And she was awarded the Defense Distinguished Service Medal there. Highest non-combat decoration.
Even after that career, she didn't stop working, did she?
Not Grace Hopper. She became a senior consultant to Digital Equipment Corporation, DEC, mostly as a goodwill ambassador, lecturing widely about the early days, her career, giving advice to vendors on serving users better.
And she still wore the uniform.
Often did. Her full dress uniform, even though it was technically against policy after retirement, it showed her immense pride. But beyond the uniform, her real impact then was on people, mentorship.
That famous quote about training young people.
Yes. The most important thing I've accomplished, other than building the compiler, is training young people.
Mm-hmm.
She said they'd come to her asking, do you think we could do this? And she'd say, try it. And I back them up. They need that. I stir them up at intervals so they don't forget to take chances.
Just incredible. Grandma COBOL, they called her.
Affectionately, yes. And she had that brilliant way of explaining abstract things, too. Made them tangible.
The nanoseconds?
The nanoseconds. Handing out pieces of wire just under a foot long, 11.8 inches. The distance light travels in a nanosecond.
Made it instantly understandable.
Exactly. And she had a 984-foot coil for a microsecond. Even used ground pepper grains for picoseconds later on. Just genius at making the invisible visible.
Mm-hmm.
The speed and scale of computing right there in your hand.
It really raises that question. What kind of impact can one person have, not just technically, but through that belief in simplifying things, defying convention, mentoring others?
It's a great question. For me, it's about seeing problems not just as roadblocks, but as, well, invitations to find completely new solutions.
Mm.
She didn't just accept the limits. She imagined a whole new human-machine interaction.
And making computers speak English was fundamentally about empowerment, wasn't it? Giving more people access.
Absolutely. And her commitment to training young people, telling them to take chances, that's so relevant today. Innovation isn't just code. It's about nurturing potential, fostering experimentation. That blend of simplification, human focus, and challenging the status quo. It's a powerful blueprint.
And her contributions were definitely recognized. Over 40 honorary degrees.
National Medal of Technology in '91.
Posthumously, the Presidential Medal of Freedom in 2016 from President Obama. A truly fitting honor.
Her legacy is baked into so much now. The USS Hopper, the destroyer nicknamed Amazing Grace, supercomputers named after her, like the Cray XE6 Hopper, NVIDIA's GPU architecture.
Even a college at Yale, Grace Hopper College.
Right. Awards in her name, National Women's Hall of Fame induction, Google Doodles, an undersea network cable. Hopper Hall at the Naval Academy, first building at any service academy named for a woman,
And the Grace Hopper Celebration of Women in Computing Conference.
which brings tens of thousands of women in computing together every year. It directly continues her mission of mentorship and empowerment. Her influence is just immense and ongoing.
Grace Hopper truly believed in making complex technology accessible and empowering others to, as she said, take chances. So, as you think about the future of technology, what new bugs do you think we need to tackle? Not just in code, but maybe in how we approach problem solving and collaboration itself. Thanks for listening. Write us your opinion in the comments on what new challenges you think Grace Hopper would tackle today if she were still here. Subscribe to the channel to help more listeners reach our episodes. Thank you and have an amazing day.